Okay, the Doppler effect is the last thing we're going to do with waves. You've heard this before. You see it with weather. I'm trying to think, astronomy has an application of the Doppler effect, but the most common one would be sirens. So what is the Doppler effect? It's the apparent shift in frequency caused by relative motion between the source and detector. So all Doppler effect is, it's the changing of what you hear as something is getting either closer or farther away. So that's why the siren is a pretty good explanation of what the Doppler effect is. It's one equation, and the only trick really is to figure out whether something's going towards or away in terms of whether it's positive or negative. So let's look at that equation. Make this bigger. Whoop. Okay, so Doppler effect. FD equals Fs V plus Vd over V minus Vs. Okay, so what do these refer to? The D is the detector, so D detector, S source, makes sense. You might also see the word observer. So D stands for the detector or the observer. And same over here, D is detector and S is the source. This plain V right here is the speed of sound, and that's going to be 343 meters per second. You might sometimes see a problem give you the speed of sound as 340 meters per second, but it will tell you what to use for speed of sound. So this 343 meters per second goes here and here for the speed of sound. This is the speed of the detector or the observer, so that's whatever's hearing the noise. This is the speed of the source, that's wherever the noise is coming from. This is the frequency of the source, and this is the frequency detected. So frequency is really what's changing in terms of what you're hearing. So a source will have a frequency that it's emitting the waves in, but this is what you're hearing it as. So how do you decide what's positive and what's negative? You're going to get this equation. So I will write this on the quiz, I'll write it on the board, so you will have this equation. This is always going to stay as plus and minus in the equation itself. What you have to decide is the velocity positive or negative, and that depends on how the object is moving. So if the source and the observer or the detector are moving towards each other, your frequency is going to increase. If your source and your observer are moving away from each other, the frequency will decrease. So that's one clue whether or not you made the right choice with these signs here, and you'll see what I mean when we actually do the example. So in other words, your higher and higher frequencies will be when the source and the observer are closer together. Your lower frequencies that you're hearing will be when they're moving farther apart. So just think about how high-pitched an ambulance siren would sound when it's closer as opposed to going farther and farther away. Okay, so sign conventions in terms of these positives or negatives. If your source is moving toward, then it's a positive velocity. If it's moving away, then it's a negative velocity. And it's the same thing for your detector. So if your detector is moving toward, you make it a positive velocity. If your detector is moving away, you make it a negative velocity. So you have to put in the positive or the negative. Really, you just have to put in a negative if it's moving away. If they're moving in the same direction, so in other words, let's say the detector is moving and the source is behind them, then one would be positive, the detector would be the detector would be negative and the source would be positive. So it all depends on how each object is moving in relation to the other one. Let's do the example. A fire truck emits a siren that has a frequency of 330 hertz. It is traveling towards a stationary observer at 45 meters per second. What frequency does the observer hear? So we've got a fire truck. Here's the siren making noise, and it's moving. And then you have a stationary observer, so the person is at rest. Our given information, we know that the frequency of the source, so source equals sound. Source is where the sound comes from. So the frequency of the source is coming from the fire truck, is 330 hertz. It's traveling towards the stationary observer at 45 meters per second. So V of the source is 45 meters per second. It's positive because it's moving towards. The observer is at rest, so that's the detector. So VD is 0 meters per second, and we're looking for the detected frequency. So FD equals Fs V plus Vd over V minus Vs. In this case, our detector is at rest, so that goes to 0. FD equals 330 hertz times 343 meters per second over 343 meters per second minus 45 meters per second. And this will come out to 379.83, keeps on going, hertz. This number is higher than the source frequency. Again, if you're getting closer towards the source, then the frequency should be higher, so that makes sense. There are only 2 sig figs, so the detected frequency is about 380 hertz. I'm going to do one more example where we're solving for something other than frequency, just so you can see how that works out. If you don't care to see how to solve for one of the velocities, then stop watching. We'll just do practice in class tomorrow. If you do want to see, then it's just one more short example. Okay, during a prison break, a prisoner who was running away from the prison hears the siren blast with a frequency of 400 hertz. But the siren actually blasts at a frequency of 440 hertz. How fast is he running? So here we've got the prison. There's a siren sounding from the prison. And obviously the prison is at rest, it can't move. And then you have the prisoner who's running away. So our given information, the frequency of the source is 440 hertz. The frequency he detects is 400 hertz. And the velocity of the source, it's at rest, is 0 meters per second. And we're looking for how fast is he moving. Frequency detected equals frequency of the source, V plus Vd over V minus Vs. In this case, the Vs is 0, so that's a little bit easier since that goes away. And I'm going to isolate and solve for Vd. So FdV equals Fs V plus Vd. Just brought the V over to the other side. Let's isolate Vd. So FdV equals Fsv plus Fsvd. FdV minus Fsv over Fs equals Vd. Let's put the numbers in. I'm just going to go to the slide so I have room. So my FD, 400 hertz, times 343 meters per second minus 440 hertz times 343 meters per second over 440 hertz equals VD. This comes out to negative 31.181, keeps on going, meters per second. It should come out to negative because the prisoner is running away. So because this is negative, it means he's moving away. So the math worked out to show us what that sign should be. We only have one sig fig, so VD is about negative 30 meters per second. So unlike what we've done before where positive or negative meant left or right, positive or negative just tell you how they're moving in relation to each other. So towards or away, it's the biggest thing you have to remember with Doppler effect.